All right. So let's take a look at this. We're asked to find the first and eighth terms and an equation for the nth term. So we have a geometric sequence here. So that's going to use all of our formulas for yesterday. That's what I had up on the board up here a second ago. So these are all the things we wrote down yesterday. Kind of our recursive definition, our common ratio formula, and our any term and the sequence piece. So when we're looking at this guy, when we have that our third term is 5 and our sixth term is 40, I'm going to start by writing this as our a sub 3 is 5 and our a sub 6 is negative 40. First thing we need to figure out is our common ratio, our R. So we know a couple of our a sub k's and we know what they equal. So what we're going to do is we're actually going to use this one down here, this formula, our a sub n. What's up? You mean the page that I had up there for the entirety of the passing period and all that stuff in the first 5 minutes I was talking? And it's all the formulas we wrote down yesterday? Not actually trying to start an ooh off, but whatevs. Okay. So our a sub n, that's the one that we're going to get with our a sub k times r to the n minus k. That guy. I know two of these pieces. I know n could be 6 or n could be 3. It doesn't really matter which one we do. I tend to pick to put the bigger number as n so that we don't wind up with negative exponents. That's the only reason I tend to do it that way, but I mean, you can do it with n being the 3. You're just going to wind up with a negative exponent, and, you know, that's a bold strategy. So I'm going to make my 6 be my n, so that will make my 3 be my k. So when we substitute in the pieces we have here, I'm going to do this in 2 steps. You don't have to do it in 2 steps, but I just want us to see where we're getting this. So by picking my n to be 6, we're going to have our a sub 6 and our a sub 3 times our r to the 6 minus 3. Yes, and that's exactly what I'm going to do in the next piece. So our a sub 3 is actually this 5. So I'm going to substitute this chunk in for the 5. And then when we're looking at our a sub 6, that's this guy. It's going to go in right there. So we're going to wind up with our negative 40. Ooh, that's not the pen I wanted. There we go. So we get negative 40 equals 5 times r to the 3rd. What's up?
Oh, I was going to say, what's the next?
What will we do next? We want to find r.
Divide by 5.
All right. I know we're squirrely and it's Friday, y'all, but we do have things to do.
And then you take the cube, the third root.
Yes. Yeah. We need to divide both sides by 5 to get my r by itself. That's going to give us that negative 8 equals our r cubed. Take our cube root, and what do we get? Negative 2 is our common ratio. Hang on a second. There's too many conversations. I know there was at least one question in that blur of noise, but there's a lot of conversations happening, and I cannot answer questions if I can't physically hear them. Questions again? I was like, I know. Because we want to figure out what r is, and if I have r to the 3rd here, I can't just cube root right here, or I'm have the cube root of 5, and then also we'll have cube root of 40, which is not pleasant. So get our exponential piece by itself so that we can do our cube root on both sides. Because it's being multiplied right here. No, valid question.
Wait, what?
That we divided because it's 5 times r cubed, not 5 plus r cubed.
What is the subtraction thing? Why is it not subtraction?
Because we're multiplying
Oh,
5
wait.
times r cubed.
I wrote down the wrong thing, never mind.
All good.
Yeah, I put it wrong.
So that gives us our common ratio, and now I can use that to find whatever terms we want to have. So I want to find my first term, so I want to find a sub 1, and we want to find a sub 8, my 8th term. So a sub 1 is the one that honestly feels the most awkward because we're going to do this same formula here, this guy over here, but we want it to equal 1. So we are going to wind up a little bit with negative exponents here. So we're going to get our, ooh, wrong pen. There we go. Our a sub 1 we can get from taking either of the pieces we know. Our a sub 3, I'm going to use that one just because we used that same bit a minute ago. So our a sub 3, you could use the a sub 6 if you want to, but we're still times our r to the 1 minus 3. So I'm just putting in the pieces we have here. We already know our r, so we can substitute that in. I know my r is negative 2. I also know my a sub 3. It's that 5 up here. So we can substitute in the pieces we know, where we're going to have our, oops, there we go, our a sub 1 that we're looking for here, we're going to get from our 5 times our r, which was negative 2, to the power of negative 2. Because 1 minus 3 is negative 2. So you can do it even if the small number's in front. That's totally fine. So we're going to have our a sub 1, that's 5 times. What is negative 2 to the power of negative 2? 1/4. So 5 times 1/4.
5/4.
5/4.
They call me the math.
Where did I lose you, Justin? Okay. Okay. Just checking. Questions on this one?
Wait, that's you, we're done?
Well, we need to do the 8th one. We did our first term.
You silly Billy.
One more piece. A sub 8. Same vibe. You can use our a sub 3 that we had before. We can use our a sub 1 that we have now. We could use our a sub 6. It genuinely does not matter which one we use. I'm just going to... We just have to subtract different pieces, yeah. So we're still going to have times our common ratio, that negative 2. But this time we're going to take our 8 to subtract the 3. So let's do this. Our a sub 8, we're going to get from our 5 times negative 2 to the 8 minus 3, which is 5. So what is a sub 8?
What?
What are we going to get here for our 8th term?
160.
Negative 160.
Okay, fine. Look at me. You know what?
Okay, so we can find a term in the sequence even if we don't have all the pieces. Let's look at another one. So this says find all possible values of r if we know these two terms. So we're asked to find r. They're just saying it weird. So we want to know what r is. So we're given two terms. We're given that our a sub 4 is 3 and our a sub 6 is 9. So we're going to work very similar to how we did on the last one. We found r on the previous one. We're going to use our formula that a sub n, which we're going to get from our a sub k times our r to the n minus k. And we have two terms here. We have two pieces. I have an a sub n, I have an a sub k. Oop, that's not the highlight. So we can have our n be 6, so our a sub n is 9. So we're going to have our 9 equals, for our a sub k, we're going to have k of 4, so that means our a sub k is 3.
Whoa, whoa, whoa.
What's up?
Whoa, whoa, whoa. Wait, why is it not 6?
Hang on a second.
Isn't the K 6 though? Yeah.
As I say, you can do the k as 6.
I mean, why would, like, I did the 9 part, but, like, I put 6 instead of
So the 6 is with the 9. So that's our n is 9, but a sub n, or n is 6, but our a sub n is 9. So let me move this down real quick. Hang on a second. I'm going to, whoop.
Oh.
Yeah, I'm going to scooch this down just a smidge, and I'll write it out again. So we're going to have our a sub 6 with our a sub 3 times r 6 minus 3. Okay, that clear?
Yeah.
What is the square root of 3?
Oh, yeah, minus 4. That way.
3 is legal like
All right, let's take a look. So what do we do next?
that? We divide by 3.
Divide by 3. So we're going to have our
Or you could have subtracted.
3. I was going to say we can do our simplifying in our exponent. Do we get 2? Yes, that should be, yes. Sorry, it was when I was like talking at the same time. Correct. That should be a sub 4, which has a value of 3. Say it in. Root, yeah. We want to get r by itself, so we need to do the square root of both sides. When I square root both sides, what else do we need to remember? Plus or minus. We don't have enough information to say if this is a plus square root of 3 or a minus square root of 3, because we have even roots here. So we have two possible options here. We don't what? Yeah, you can leave it as a root. We don't need to make it a decimal. So our possible values of r are positive or negative square root of 3. We have 2 it could be. And we don't have enough information to clarify it in any other way. All we are asked to find is r. We aren't asked to find any other values. Okay. Questions on this one? We're going to have another one very much like it so we can practice this again because I know they're weird.
This would have been false.
Another kind of very similar one. I've got a sub 4 is 1 and a sub 7 is 27, and we're asked to find all possible values of r. So our very similar vibe from the last one. We're going to have our a sub n.
Negative 27 equals 1 times r to
I'm going to write our in-between steps out just because I know that's going to be helpful for some of us. So our n, I'm picking my n to be 7, so we're going to have our a sub 7 equals our a sub 4 times our r to the 7 minus 4. Again, you don't have to put them in those particular spots. just this way gives you the fewest negative exponents if you do the biggest one as your n, our biggest term. So then our a sub 7, we know that value, that one's worth 27, or negative 27, excuse me. And our a sub 4 is worth 1 times our r. 7 minus 4 gives us 3. Where do we go from here?
We divide by 1.
Divide by 1. So we have negative 27 equals r cubed. Cube root it. Yeah. So we're going to take our cube root of both sides. And we get that negative 3 equals r. Do we put a plus or minus on it?
No,
No, why not?
because it's a negative then.
Because it's an odd degree. Odd degrees do not get the plus or minus. We only put the plus or minus if it's an even degree, like squared or fourth. Because those are the ones we cannot tell sign. With odd degrees, we can tell the sign. Questions on this one? Okay, now we're going to combine those kinds of questions where we're going to find the r and then we're going to find the more values. Bless you.
We couldn't use the r equals the ak plus 1 over
You can only do that if we have sequential terms because it's k plus 1 over k. So it would have to be like r sub 5 over r sub 4 or 7 over 6. So they have to be neighboring for the ratio to work. Yes. So here we go. We are going to find a sub 7 if we know a sub 1 is 4 and a sub 3 is negative 1. I'm sorry, a sub 1 is negative 4, a sub 3 is negative 1. And we're going to try and write the equation for our nth term. So first thing we need to figure out is r. So this is the kind we've done a whole bunch of times already today. Our a sub n equals our a sub k times r n minus k. We have two pieces up here, so I'm going to have my 3 and my 1. Negative 4 times r to the power of 3 minus 1. Fix that handwriting because that's trash.
And then we divide by negative 4, which is
Ooh, slow it down, slow it down, slow it down. What do we do first?
negative 1 divided by negative 4.
Negative 1 divided by negative 4 gives us what?
1/2.
Whoa, there we go. There we go. Slow it down. Slow it down. We got our r squared.
Okay, but if we want to test, we'll get it right.
I was going to say, slow it down, slow it down, slow it down. You were trying to run. So then we square root both sides. And
We're about to say 4 root 2 divided or something.
what did we forget when we square rooted both sides? Plus or minus.
Then how are we?
This is all Justin's fault.
Unless we actually get them.
Where? Okay. We have an even degree here, so we can't tell what sign. We still have this plus or minus. We don't know if they're continually multiplying by positive 1/2 or continually multiplying by negative 1/2. We don't
So
know.
when we find A7, do we put plus or minus for our answer?
We're gonna work it like that. Let's look at it.
Is it gonna get progressively harder?
Say it again.
Is it gonna get progressively harder?
Not really. It's like it looks gross, but I promise it's really actually not. So let's look and see what happens when we look for that a sub 7 term. So we're using very similar bits here. I know my a sub k. We can use our a sub 1 again. Times our r But we know our R, so I'm gonna put that in. I'm just gonna put it as the plus or minus 1/2. We'll see what happens as we get going here. I'm just gonna put it like that because we don't know yet. So then we're gonna have our 7 minus 1.
You guys did it twice, right? Plus and
I was gonna say, if yes, we would do it twice, once for the plus, once for the minus if we need to. So our a sub 7 is the guy we're looking for. Give it a second, just be patient with me, I promise. Got our -4. We've got our plus or minus 1/2. What's our exponent gonna be? 6. So we have our a sub 7. -4. What is 1/2 to the 6th? 1 over 64. What is -1/2 to the 6th?
It's still the same.
Still the same because it's an even degree, so it's going to wind up positive anyway.
Oh, so you're right there.
So we get -4 times 1 over 64. So we don't have to do it twice. It just kind of is where it is. So our a sub 7, we start out with, well, it's -4 over 64, but what does that simplify down to be? Mm-hmm. -116.
So if you have a plus minus one, like,
Mm-hmm.
even whatever, it would end up as one solution and one answer, not like a plus or minus.
So if our plus or minus has an even power, it's going to wind up as it's positive.
If it's not even,
Then we would have 2 answers.
okay.
So let's look and see what that would look like, because we're going to write a rule for our nth term, and we don't know for our nth term if it's going to be an even degree or an odd degree. So let's take a peek at that. If I want to write an equation for my a sub n, we can use all those same pieces again. I can still start with my -4, my a sub 1. And we would put in our ratio with that positive or -1/2 to the n minus 1. So if I was looking to write our a sub n equation one individually, there's not really anything else we can do. I'm just going to have them one be a plus and one be a minus. It's really,
Why can't we substitute -1 over 16 for 8? Wouldn't that technically,
so if I was wanting to find a sub 7, that would be when I would put that in here, or 1 over 6/5. We're writing our equation so that if I wanted to find term number 20 or term number 300,
oh, okay.
I could plug it. So this is one option for my equation. Or we would have our -4 and our -1/2 to the n minus 1. One of these is going to be true, and we just don't have the information to be able to do that right now, because everything we have has an even degree when it gets to the point of calculating the exponent. So it could be either one of these. So both of these equations would count. And you could write it like this as long as we're aware of that. Either way you write this is fine. But these are our a sub n pieces for our equation. And those are chunky highlights. Okay. Let's do another one. So we're asked to find a sub 10 if we know that a sub 4 is 4 and a sub 7 is 12. And we're going to write the equation for n.
So 12.
We gotta find R.
We got to find r first, because we don't know our r yet.
4 equals 12 times R.
Yeah.
4 minus 7.
12 equals 4.
No, yes.
Yeah.
Well, add more right than you
No,
are.
that was.
Where did I?
I'm just gonna like write the pieces down because it's a little easier sometimes to find it or to follow it when we're writing it.
Oh,
So I'm substituting the pieces we have.
I'm not weird, I'm sorry.
For some of us, this step is really, really helpful. If this stuff helps you, please write it. You do not have to write it, but
It is recommended if needed.
that is not even kidding. That is a very leisurely against that wall. That's all it takes. I'm just saying, it happens all the time, which is why when it comes to finals, you will find red signs along both of these walls outside saying, stop bouncing on the walls. Because people stand out there and they just like bounce against the wall. And I'm just like, it sounds like a drum in here when they do that. Which, I like percussion. I was a percussionist. I don't want to be inside of a drum. And then our exponent here, our 7 minus 4, is a 3.
Ooh.
So what are we getting over here?
I don't know. 3 equals.
3 equals our r cubed.
And then what?
I'm gonna keep it as a root. Cube root of 3
That's too much, though. Go.
equals our r. I would say you could also do this as our fractional roots or fractional index. So we could write this as 3 to the 1/3. Either way is fine. Since we're gonna have a lot of exponent stuff, sometimes it is easier to do it in exponent form. But either way of writing that is totally fine. So if we look for our 10th term, our a sub 10, y'all are weird sometimes. So I'm going to take and use my a sub 4 again. You could use either one here. You could use our a sub n. You could use the a sub 7. Doesn't really matter. But we know our r now. I'm going to use the fraction exponent rule. Mm-hmm. To the power of 6.
And then you multiply the exponent, right?
Mm-hmm. Yeah. So if we're looking at this, when we have something like cube roots or square roots, sometimes it really, really, really is easier to deal with it in the fraction exponent form because our exponents here are 3 to the 1/3 being raised to the power of 6. Exponent rules becomes 3 squared. 1/3 times 6. So it's 9 times 4. 36.
Whoa.
You're such a nerd. Because I know how to square. Yeah. Basically.
What is 4 times
You wish I knew, huh?
That's when you use the hand trick.
9?
Oh, yeah, the hand trick.
Oh, I use that for 9s constantly. Constantly. I was never really good at like the speed math tests like back in the day. No.
I would eat
Like cuz that is not the way that my brain works. It is not a set of flashcards in my head. I think of every single time. Was it? No. All right, let's get our a sub n.
Wait, how did we get to 3 squared?
That was 3 to the 1/3 because that's cube root of 3 being raised to the 6.
How do you do that? Well, you just like
Multiply.
right?
Yep. 1/3 times 6 gives us 2.
You learned that in algebra.
You know what, Justin?
That's okay. It's been at least some time since we did that.
Get your beautiful self.
All right, let's get a generic equation.
Okay. AN equals A4
We can do that. We could do a 4.
4 times
With n minus, wait, no,
n minus 4.
And minus 4. So substitute in our values because we want to have as few variables as possible. So we've got our 4.
4 3 1. Oh, so you can have multiple rules for the nth term?
Mm-hmm. I could come in here and I could write this as our, with our 12. We could do our 3 to the 1/3, and it would just be that we have n minus 7. I could go through and find my first term, so we could do n minus 1, and it would wind up, it actually would be 4/3. You could come through and we could just like deal with our powers and do that since we are adding or subtracting. I could get decimally versions. Like there's a lot of ways to scooch these around and make different kinds of equations. So there's not necessarily one correct formula for a sub n. There's lots of different ways to write it that will all give us the same answers.
So when you're like grading stuff, you have a key with all of them?
I write down the most common ones that I see, or if I see new ones, I'll just double check them. But yeah, there's a lot of options. That's why you don't give you tons of choices, and we don't usually ask you to find the first 5 terms and then write an equation. That's too many things for me to look at. Okay. Questions on this bit? All right. I'm going to put up like the next piece, because just like we had arithmetic means, we're going to have geometric means, which is the same thing where we're putting the C in and we want the R to make it an arithmetic sequence. So it's going to be not that they plus 2 plus 2 plus 2, but they'll times 2 times 2 times 2, whatever it is. So we're basically making an exponential sequence. So it does the same thing, and it uses, honestly, pretty much the same formulas we've just been doing. We just are numbering them ourselves. So it's the overcomplicated way of saying it, but what they're saying is if we have our A and our B, and we want to put a geometric mean in the middle, we have our A sub 1, our A sub 2, and now our A sub 3, and we need this to be a geometric sequence, so we will use our A sub n, A sub k times r, n minus k. We're going to use that guy to figure out our ratio so that we can find our new pieces. So it has to make a geometric sequence. It has to make a chain of numbers that multiply between them, not add between them. So our arithmetic sequence is added, 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 because in arithmetic we add things together. And geometry, we did a lot of our areas, we do a lot of multiplying. So geometric is multiplying.
Also, we just switch from multiplying to from adding.
Arithmetic, we add things. Geometric, we multiply.
But the equation really doesn't change. It's the same pages.
Yeah. It's just whether or not we're looking at a geometric sequence or if we're looking at an arithmetic sequence. So let's try one. We're going to find a geometric mean between 20 and 45. Meaning I want to find the number that would make 20 and then something and then 45 be a geometric sequence. So I want this guy to be my first term, this guy to be my second term. I don't know what that is. I'm going to rewrite that letter because that letter was crazy. And our A sub 3 is our third time. It's 45, not 4.5.
1.5.
For what? What's 1.5?
Like
Yes, but let's do the work and show it.
No.
Oh my gosh, I know I'm horrifyingly cruel. We'll probably just do this one. Let's see. So we've got our two pieces here. I've got a first term, I've got a third term. We know we've just done a whole bunch like this. I can find another term using this guy. That's an n. So I know my a sub 3 needs to equal my a sub 1 times whatever our ratio is to the 3 minus 1. I know. So we're going to have our 45 equals 20 times r squared. What do we do next? Divide by 20. Get 45 over 20 is r squared. That's the same thing as 9 over 5, or 9 over 4. So if we take the square root, what do we get? What's our r?
The pivot. 1/4. What? I forget.
3 over 2. This is not 1/4. This simplifies down to be 9/4 if you do that.
And then 1/4, like divide by 9. I was figuring
Okay, technically it would be plus or minus. Since we know we're finding a mean between, we get to pick. Generally, we're going to pick positive because I don't want you to be mean to yourself like that, because ew. We're finding a geometric mean in here, not finding necessarily all. So we know it's going to have that common ratio. It's going to multiply between them by that 3/2, or that 1.5. It's going to multiply between. So what is C going to be? Yep, we're going to take our 20 times that 3/2. So we get 30. So a geometric sequence would be 20, 30, 45. That is a geometric sequence. So the geometric mean between 20 and 45 is 30. It's the geometric mean. Okay, we'll practice more with those next week. I just wanted to kind of get that in there because I know that's a big part of that homework for 10-3. So, what's that? Made of unicorn kisses and angel farts. The cloud, the rolls from Texas Roadhouse. They're made of unicorn kisses and angel farts.
no.
They're made of unicorn kisses and angel farts. They're the best thing ever.